Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. Today we are starting first example from question number 2 from miscellaneous exercise 6b. Observe the first example. In this example we are finding vector equation of the plane which is at a distance 5 units from the origin. Distance of the plane from the origin is given to us and which is normal to the vector, and vector along the normal is given to us. If distance of the plane from the origin is given to us, at that time to find out equation of plane we are applying what? Normal form. And what is the normal form? R bar dot n cap is equals to p. Means applying this formula we are able to find out equation of plane where p is nothing but distance of the plane from the origin and n cap is nothing but unit vector along the normal. If these two values are known to us, we will get our required vector equation of plane. So here vector along the normal is given to us. We have denoted this vector by what? N bar. N bar be the vector along the normal to the plane. But to apply this formula we will require the value of n cap, means unit vector along the normal, and unit vector can be find out as, what is the formula to find out unit vector? N bar divided by its magnitude. Means to find out n cap we will require magnitude of n bar also. So first we are finding magnitude of n bar. Magnitude of n bar is equal to under root 2 square plus 1 square plus 2 square, which is equal to, just we can observe that 4 plus 1 5, 5 plus 4 is 9, and what is square root of 9? 3. So value of magnitude is known to us. So find out unit vector. Unit vector means what? N cap. So therefore unit vector n cap along the normal is n cap is equals to n bar divided by magnitude of n bar. What is the value of n bar here? 2i cap plus j cap plus 2k cap divided by magnitude of n bar. What is magnitude of n bar? 3. Once the value of n cap is known to us, then which is second required value? P. P means distance of the plane from the origin, and here distance of the plane from the origin is already given to us. What is that distance? 5. So distance of plane from origin is P is equals to 5 units. It is given to us. So therefore we can say that vector equation of plane is, and what is the formula? Formula is what? R bar dot n cap is equals to P. Now remaining part is just to substitute the values. Keep this R bar as it is, dot also as it is. I am substituting the value of n cap. So this is the value of n cap here, 2i cap plus j cap plus 2k cap divided by what? 3. And on this side substitute the value of P. P is equals to how much? 5. P is equals to 5. This implies that, so this 3 is divided on this side it will get multiplied with 5. So what is the remaining term on left hand side? R bar dot 2i cap plus j cap plus 2k cap, and on the right hand side 3 5s are 15. So in this way we have got our required vector equation of plane. Okay, now observe the example number 2. In this question we are finding perpendicular distance of the origin from the plane. So we have to find out distance of this origin from the plane, or in other word we can say that distance of plane from the origin. And if we are able to convert this Cartesian equation in normal form, so what is the normal form? Lx plus my plus nz is equals to p. If the coefficients of x, y, z are L, M, N, means direction, cosines of normal to the plane, at that time we can say that equation is in normal form. And if equation is in normal form, then value on the right hand side means P is nothing but what? Distance of the plane from the origin, or we can say that distance of the origin from the plane. So first we are trying to convert the given Cartesian equation in normal form. So here A is equals to, so here A is equals to what? 6, B is equals to what? 2, and C is equals to what? 3. So before that let us write down this equation as. So what is the given equation here? 6x plus 2y plus 3z minus 7 is equals to 0. So can be written as, that is 6x plus 2y plus 3z minus 7 on this side will become what? Plus 7. Let us denote this equation by equation number first. And we know that coefficients of x, y, z are nothing but direction ratios generally, and we are denoting direction ratios by what? ABC. So A, B, C are direction ratios of normal to plane. So therefore under root a square plus b square plus c square is equal to, why we are finding value of under root a square plus b square plus c square? Because once the direction ratios are known to us, a upon under root, b upon under root, c upon under root are nothing but what? Direction cosines. And if coefficients of x, y, z are direction cosines, at that time value on the right hand side is distance of the plane from the origin. So that's why we, to convert to find out direction cosines, we will require this value. So substitute the value. A square means 6 square, b square means 2 square, and c square means 3 square. So here what is square of 6? 36 plus 4, 40, 40 plus 9, 49. And what is the value of root 49? Root 49 will be equals to what? 7. Now we are dividing both sides of this equation by 7. By 7 means what? Value of under root. And this 6 means what? A upon under root will be the coefficient of x. 2 means what? B. And b upon under root means the value of what? M. And c upon under root means value of n. Means in short, we are trying to convert this equation in what? Normal form. So divide both sides of equation first by what? 7. If we are dividing both sides of this equation by 7, we get, let us see what result we will get here. So here we will get 6 by 7x plus here we will get 2 by 7y plus here we will get 3 by 7z, and on this side 7 upon 7 will be equals to what? 1. So here we can say that this is equation of plane. This is equation of plane in which form? In normal form. In normal form. Once the equation of plane in normal form is known to us, at that time the value on the right hand side is nothing but what? Is nothing but distance of the plane from the origin, or distance of the origin from the plane. So therefore distance of origin from plane first is how much? Plane first means this equation of plane we have denoted by equation 1. So distance of the origin from plane first is how much unit? 1 unit. And this is the value which we have to find out here. See, in this third example, we are finding the coordinate of the foot of perpendicular drawn from origin to this plane. So let us consider this will be the origin and this will be the given plane. And question is to find out coordinate of this foot of perpendicular. So now first we have considered equation of plane. Let us suppose that distance of this plane from the origin is P, and if the direction cosines of the normal to the plane are L, M, N, if these values are known to us, we can say that coordinates are what? LP, MP and NP. Already we have proved this result when we have discussed equation of plane in what? Normal form. Later on we have written this result as a note to find out coordinate of foot of perpendicular. Means to apply this result we will require L, M, N, means direction cosines of the normal, which can easily be find out from the given equation of plane. And P means what? Distance of the plane from the origin. Means to find out value of L, M, N and P, we have to convert this equation in what? Normal form. So let us try to convert it in the normal form. So here we can say that A is equals to 2, B is equals to 3 and C is equal to 6 are direction ratios of normal to plane. So since these are the direction ratio, to find out direction cosines, we will require the value of under root a square plus b square plus c square, which is equal to under root 2 square plus 3 square plus 6 square. Just simply substitute these values of a, b, c. See what we'll get here. 36 plus 4, 40, 40 plus 9 will be 49. Means sum of square of these three number is 49. And what is square root of 49? 7. So now once this value is known to us, so these are what? A, b, c. And this is the value of what? Under root a square plus b square plus c square. So then a upon under root, b upon under root, c upon under root are nothing but what? Direction cosines. Means in short, to convert this equation in normal form, we have to divide to this equation both side by what? 7. So divide both sides of equation first by 7. Let us see what we will get after dividing both sides by 7. So here we will get 2 by 7x plus here we will get 3 by 7y, here we will get 6 by 7z, and on this side 49 upon 7 will be equals to what? 7. Now we can say that this equation is in which form? Normal form. So this is equation of plane in normal form. Once the equation of plane in normal form is known to us, easily we are able to find out direction cosines also, and value on the right hand side is what? Distance of the plane from the origin. So therefore we can say that L is equals to 2 by 7, M is equals to 3 by 7. These coefficients of x, y, z are nothing but what? Direction cosines, since the equation is in what? Normal form. So N is equals to 6 by 7 and P is equal to what? 7. So P means distance of the plane from the origin. So once these values are known to us, so this formula is applicable to find out coordinate of foot of perpendicular. So here we can say that, so therefore coordinate of foot of perpendicular are, so what are the coordinate of foot of perpendicular? LP, MP and what? NP. Remaining part is just to substitute the value. What is the value of L? 2 by 7 into P. P is how much? 7. Y coordinate is what? M. M means what? 3 by 7 into P. P is how much? 7. And lastly, let us try to find out value of Z coordinate, means value of NP. N is here 6 by 7 into P. P is what? 7 here. So therefore what result we have got here? Here 7 7 will get cancelled. X coordinate is 2. Here 7 7 will get cancelled. Y coordinate is 3. Here also 7 7 will get cancelled. Z coordinate is how much? 6. In this way we have got the coordinate of foot of perpendicular. Now in the example number 4th, one equation of plane is given to us and we have to reduce this equation in normal form. So already here equation of plane is in Cartesian form, and here we have converted this equation in what? Normal form. So this vector equation we have to convert it in the normal form, means same method we are applying which we have applied in case of what? Cartesian equation. And once this equation is converted into normal form, easily we are able to find out these values. What is the first value? Length of the perpendicular from the origin to the plane, and direction cosines. Here also we have got length of the perpendicular. P means what? Length of the perpendicular from the origin, and direction cosines also. So let us first consider the equation of plane here. So solution. So here equation of plane is, what is the equation of plane? R bar dot 6i cap plus 8j cap plus 24k cap is equals to 13. So here we can say that direction ratios of normal to plane are. So what are the direction ratios? A is equals to 6, B is equals to 8 and C is equals to 24. Once the direction ratios are known to us, find out the value of under root a square plus b square plus c square, which is equal to under root a square means what? 6 square, b means what? 8 square, c means what? 24 square. So which is equal to, we can observe that here we will get 36 plus 64 plus what is square of 24, square of 24 is 576, isn't it? So its addition will be equals to, what is the addition? 36 plus 64 is 100, 100 plus 576 is 676, and we know that square root of 676 is equal to how much? 26. So now we are dividing both sides of this equation by what? 26, to convert it into what? Normal form. So therefore, or divide both sides. Divide both sides of equation first by 26. Let us see what we'll get. So here r bar, keep it as it is, dot also as it is. What will the first term? 6 upon 26 I cap. Here if I am dividing by 26, what will get? 8 upon 26 j cap. Here we will get 24 upon 26 k cap, and on this side we will get 13 upon 26. So this equation can be written as r bar dot, both the numbers are divisible by 2, so here we will get 3 upon 13 I cap. So if I am dividing both numerator and denominator by 2, so here we will get 4 upon 13 j cap, and lastly if I am dividing here numerator and denominator by what? 2, so what we will get here? 12 upon 13 k cap, and on this side both the numbers are divisible by what? 13. So 13 ones are and 13 twos are 26. Now this is the equation of plane in what? Normal form. This is its equation of plane in normal form. So in this way we have converted this equation in which form? Normal form. So from this equation easily we are able to find out our required values. So what is our first required value? The length of perpendicular. So the length of perpendicular from the origin to plane is, and if the equation is in normal form, at that time value on this right hand side is nothing but what? Distance of the plane from the origin, or we can say that length of the perpendicular from origin to the plane, means what result we are getting is 1/2 units. Now second required value is what? Direction cosines of the normal, and direction cosines of normal are, what are the direct coefficients of I cap, j cap, k cap? Are nothing but direction cosines when the equation is in normal form. So 3 upon 13, 4 upon 13, and lastly what we have got here? 12 upon 13. In this way we have got what? Direction cosines of the normal, which is second required value. Now let us try to solve the question number 5. In this question we are finding vector equation of plane passing through 3 points. So if coordinate of 3 points on the plane is given to us, at that time to find out vector equation of plane we have one formula, that is r bar dot AB bar cross AC bar is equals to A bar dot AB bar cross AC bar, isn't it? Now to apply this formula we will require the value of AB bar. AB bar can be find out as what? B bar minus A bar. In the same way AC bar can be find out at what? C bar minus A bar. And what is this A bar, B bar, C bar? Are nothing but position vector of these 3 points. So first define the position vector. So we are supposing that here let A bar, B bar, C bar be the position vectors of points A, B and C respectively. So therefore A bar will be equals to, from coordinate of point A, what will the value of A bar? I cap minus 2j cap plus k cap. What is the value of B bar from its coordinate? 2i cap minus j cap minus 3k cap, and C bar is equal to, what will the value of C bar here? J cap plus 5 k cap. Once these values are known to us, then we are finding value of AB bar. AB bar can be written as what? B bar minus A bar. So substitute the value of B bar. Value of B bar is equal to 2I cap minus J cap minus 3K cap minus A bar. A bar is equal to I cap minus 2J cap plus K cap. Now take the difference. 2I minus I will be equals to I cap. Minus J and minus minus means plus 2J. Plus 2J minus J plus 2J will be equals to J cap, and lastly minus 3 and minus 1 K cap will be equals to minus 4 K cap. Value of AB bar is known to us. Then find out value of AC bar. AC bar is equal to C bar minus A bar. What is the value of C bar here? J cap plus 5 K cap minus value of A bar is equal to I cap minus 2J cap plus K cap. Now take the difference. Here term of I cap is missing. Its meaning is that its coefficient is what? 0. 0I minus I will be equals to minus I. Then J minus minus means plus 2J means 3J. Here J plus 2J is 3J, and 5K minus K will be equals to what? 4K. In this way we have got the value of what? AB bar and value of what? AC bar. So now we are trying to find out the value of cross product. Which cross product is required here? AB bar and AC bar. So therefore AB bar cross AC bar will be equals to, we know that cross product can be found out using what? Using determinant. In the first row write down I cap, J cap, K cap. In the second row write down the coefficient of I cap, J cap, K cap from AB bar, that is 1, 1, minus 4. Then write down coefficient from AC bar, that is minus 1, 3, 4. Let us simplify it. First we are trying to find out coefficient of I cap. Delete this column. 4 minus minus plus 12. 4 plus 12 is 16. Here plus J cap is there, so take minus J cap here. Delete this column. This product is 4. 4 minus 4 will be equals to 0 plus K cap. Lastly let us try to find out coefficient of K cap. Delete this column. 3 minus minus plus 1. 3 plus 1 will be equals to what? 4. In this way we have got the value of AB bar cross AC bar. So therefore vector equation of plane is, just remaining part is to substitute the value. What is the value of this cross product? 16 I cap plus 0 J cap, not necessary, 0 plus 4 K cap. And on this side first substitute the value of A bar. What is the value of A bar here? I cap minus 2J cap minus plus K cap. Keep this dot as it is, then substitute the value of this cross product. Already here we have substituted that value, 16 I cap plus 4 K cap. Okay, so on this side just simply we have to find out value of this dot product. Whenever two vectors are in Cartesian form, at that time first take the product of coefficient of I cap, then J cap, then K cap, then take their addition. So what is the product of coefficient of I cap? 16, and here product of coefficient of J cap. Here term of J cap is missing, means here its coefficient is 0. 0 into minus 2 is 0, and lastly 1 into 4 will be equals to what? 4. So here 16 plus 4 will be equals to 20. Keep this left hand side as it is. R bar dot 16 I cap plus 4 K cap. In this way we have completed first 5 example from question number 2. In the next video we will try to solve remaining example from question number 2.